Today I'd like to talk about Gaussian pyramids and what it is, why we use it, and a little bit of introduction of how it works. So a Gaussian pyramid essentially takes an image and we keep on reducing the size of the image until it is 1 pixel in size. And that's why it forms a pyramid. And Gaussian means that we're taking a Gaussian blur on the smaller image. So every time the image becomes smaller, it also gets more blurry as we lose more details. So as we have an image that gets smaller and smaller, it is also more and more blurred. And the reason that it's more and more blurred is we take an original Gaussian filter and we apply it on a smaller image, then that has the same effect of increasing the size of the filter. And as we apply the same filter to increasingly smaller images, then that's the same as increasing the standard deviation on the filter. So the filter is effectively getting larger and larger. So you get more and more of a blur as the image gets smaller, and you're still using the kernel, the Gaussian kernel of the same size. So in that way, you would have an image that's more and more blurred. So to illustrate this example again, we have an image that is 256 by 256. Now, this original image is what we're going to call G0. And a smaller image, this is the second layer of the pyramid, is going to have 128 by 128. And we're going to call this G11 because we applied one standard deviation, one Gaussian filter on it. And the next level will be 64 by 64, and this level is going to be called G22. And if we take the difference between this original image with the original resolution and this new image with its new but less resolution, then we have the difference of the Gaussian filter. And this creates another image which gives us the details, the difference in details from here to here. So this image would have the details. So essentially, this is the Laplacian pyramid. And this Laplacian pyramid gives us the difference in details at each level. So here we will have another filter. So L0 is our first difference in detail. L1 is the second difference in detail. So this difference essentially approximates the second derivative of the Gaussian function. So then as we move more and more down this way, the difference in details is going to be less and less. So this is going to have lots of detail, this is going to have less detail, and eventually it will be very blurry and the details are not there. So if we take this blurry image and we add the difference in details, we should be able to get back to this image of the original resolution. Now there is some trick to actually, because the size of these two images are different, so you will need to have this image be expanded into the same image size before you can add details onto it to get the image of the original resolution. But that's something else. It's like another topic that we can go into. But yeah, that's pretty much it in terms of Gaussian pyramids and Laplacian pyramids. Now, one of the uses for this is how do you Suppose you have an image that's very large, but you want to display it on a smartphone, and the smartphone has much lower resolution than your desktop wallpaper. This is one way to do it, to shrink the image. Compression algorithms uses this way to recover images back to the original resolution if you have this Laplacian pyramid. And that's an introduction into Gaussian pyramids and Laplacian pyramids.